Morning, students. Miss Connor again. Today's date is March the 21st. This is for the lesson for the 21st and the 22nd. Got 4 classes until the end of the quarter. Telling you, it went by real quick. So for today's class, you're going to need a pencil, a copy of the classwork, which is also on the website under the March 17th and March 18th classwork section. Homework ready for review, which was also adding and subtracting polynomials. I put it on a pink copy sheet, but on the website, obviously, this is a plain white copy. And we're also going to need loose leaf paper for notes. So first things first, I went over the 3 problems from the homework. And the first problem is 3z squared minus z plus 2 plus z squared minus 4. So I'm going to have to do it from the laptop, so this is going to be all kinds of fun and funky. So first things first, we need to put it in descending order based on our degrees. So what is the highest degree? In this count, my highest degree is to the 2nd power. So we want to organize it. So we have our highest degree first. So it's 3z squared plus z squared. Okay, so that takes care of all of my 2nd degrees. Now I need to see what's in the 1st degree. So right now it looks like I just have this minus z. Okay, any other z's up here? Nope. And lastly, we need to get all our constants together. So that's going to be that plus 2 and that minus 4. So as we mentioned before, we want to combine or basically look at our exponents, aka our degrees, to help us match our like terms together. So in this case, in blue, I have that 3z squared plus z squared, which gives me 4z squared. And the reason why it gives me a 4 is because in front of this z, there's a 1 that's understood to be there. Now, going with the z's, all we have is that minus z. And then 2 minus 4 will give me a negative 2. And this right here is my answer. So I know it looks a little bizarre, besides the handwriting, but for the most part, all we're not doing anything with the exponents. When we're adding and when we're subtracting, we're using those exponents to match up our like terms. Unlike when we're multiplying and dividing, when we multiply, we added our exponents, and when we divide it, we subtract them. So that was number 1. So number 2, we have 2y to the 3rd plus 3y minus 2 plus y squared minus 2y. So first things first, we're adding, so we need to get our like terms together. What's my highest degree? My highest degree is the highest exponent, and it looks like this cube is my highest exponent. So since this is my only cube, that means the 2, the coefficient of that y cube, that's my leading coefficient. Remember we talked about that last class? So since it's 2y cubed, okay, we don't have any other y cubes up here. So now we need to go to the next degree, which is y squared. So right now I only have one of them, and it's positive, so plus y squared. Okay, and then now I got some y's left over. So I have a plus 3y and a minus 2y. Okay, anything left over? Yes, we have this minus 2 left over. So now let's get our like terms together. So with this 2y cubed, it seems like that's the only one that's there, so I just bring it down, 2y cubed. And the y squared, I don't have any other y squares up here, so I'm just going to bring that plus y squared down. And then in green, I have 3y minus 2y, which will give me a positive 1y, or I can just simply write plus y. And then I don't have any more constants, so I'm just going to simply write negative 2. So my solution to this will be 2y cubed plus y squared plus y minus 2. And the last one that I had you guys do, because I only had to do the ones for addition. So that was problems 1, 2, and 3. So for number 3, we have 8b cubed plus 7 plus 5 minus 3b cubed. So first things first, what's my highest degree? My highest degree is this cubes. And it looks like I have 2 of them. So let's write them down. So we have 8b cubed minus 3b cubed. Any other cubes up here? No. All right, so do we have any b squares up here? No. How about just plain old b's? Nope. So then what's left are my constants. So plus 7 plus 5. So now 8b cubed minus 3b cubed, that will give me 5b cubed. Ooh, it's getting ugly. Oh, it's getting ugly. Plus 7 plus 5, that'll give me 12. So it looks right now, since I can't combine anything here, my solution is 5b cubed plus 12. Okay? So that was just used as a refresher for adding polynomials. So most of the time, most of the students were just basically checking their answers. So to continue on, as promised, I said we're going to talk about subtracting polynomials. And the key thing still continues on with addition. The key part of adding and subtracting polynomials is to find like terms. But when we're subtracting polynomials, it's best to remember either the phrase keep, change, or the phrase keep, change, switch. This change and this switch means exactly the same things. So they're interchangeable, okay? So that's important for us to remember. So I like to do this through examples, and we're going to do a total of 5 of them. So for number 1, we have 2x squared minus 4 minus x squared minus 1. So going with the phrase keep, change. This first parenthesis, I'm actually going to keep it. Meaning, I'm going to keep the signs, keep everything in its order, don't change a thing. But in this, in between, this minus sign, I'm actually going to change. And I'm going to change it from a minus, oh, I know it's ugly, but I'm going to change it to a plus. And lastly, when I make this change from a minus to a plus, I'm also going to change just the signs of everything in this last parenthesis. Hence the steps keep, change. So then originally this is a positive x squared. I'm going to make it a negative x squared. And this is a minus 1, and now I'm going to make it a plus 1. Okay? So if I wanted to, I can do exactly the same thing as I did for addition. So I'm going to get my like terms together. In this case, my like term is a 2x squared minus x squared. And the reason why I'm using the 2x squared is because that 2 is my highest degree. I want to do it in descending order. So I took care of my x squares, and what's left over right now? So it looks like I have a minus 4 and I have a plus 1. Because remember, we changed it to a plus, okay, based on that whole keep, change. So now let's clean it all up. 2x squared minus x squared will give me 1x squared, or just simply x squared. And this negative 4 plus 1 is going to give me a negative 3. So my solution to this will be x squared minus 3. And the reason why I like to say keep, change, what I'm basically doing, I'm distributing this negative to everything inside the parentheses so I can do it through addition. So if I can do it through addition, it'll be a lot easier. The reason why I have you guys do this, because I know visually you're going to say, all right, 2x squared minus x squared is going to give me an x squared. Beautiful. But this is what always happens. When you get to the negative 4, you're not going to say negative 4 minus a negative 1. Your eyes is going to say, all right, negative 4 minus 1, that means I should have a negative 5 here. And that's not the case. By doing the keep, change, it will help you to remember that you have to change the signs of everything in this second parenthesis. Let's look at another example. So for example 2, we have 4x to the fourth minus x squared plus 1 minus x to the fourth minus 2x cubed plus x squared. Can you see I've been saying this all day? So here we go again. We're doing subtraction. So since we're doing subtraction, I want to keep this first parenthesis, meaning I'm going to leave it alone. But now I want to change my minus sign to a plus sign. And then I'm going to change my last set of parentheses from positives to negatives. So instead of a minus sign, I'm going to make it a plus sign. Instead of a positive x to the fourth, it's going to be a negative x to the fourth. Instead of a minus 2x cubed, it's going to be a positive 2x cubed. And instead of a positive x squared, it's going to be a negative x squared. Okay? So now I want to order it in descending order, just like I did with addition, starting with my highest degree. So what is my highest degree in this case? Hopefully you said to the fourth power. So now I want to write down everything that has association with x to the fourth power. So we have 4x to the fourth minus x to the fourth. Let me make this a little bit longer. Okay, so that took care of my raised to the fourth power. Now the next degree down will be to the cube power. So I have now it's a plus 2x cubed. Okay, do I have any other x cubes up here? No. So now I want to work with the squares. And I have a minus x squared and another minus x squared. And hopefully you're able to see where all this is coming about. And then what's left over is my plus 1. So the 4x to the fourth is here. This negative 4x to the fourth is there. Then you have 2x to the third is here. Then you have a negative x squared that goes here, and this negative x squared that goes there, and then what's left over is that plus 1. So now, let's get our like terms together. So 4x to the fourth minus x to the fourth, remember, there is a 1 that's understood to be there. So that will make it a 3x to the fourth. Then I work on my plus 2x cubed. Now this one, a lot of students were telling me that my x squares cancel out. The only way these x squares can cancel out if this one is a positive and one is a negative. That's not the situation. The situation is I have a negative 1 minus 1, which will give me a negative 2x squared. And then for my constant, I have my plus 1. So then here is my solution. So I have 3x to the fourth plus 2x cubed minus 2x squared plus 1. Okay? So you have to really pay attention to adding and subtracting your integers. Okay? Not so much the gathering. I do notice that you guys are able to gather up your like terms. But what you do with those coefficients, you really have to pay attention to. Okay? That's why it's so important to keep that whole process of keep, change throughout. Okay? Let's try the third one. So we have 5x cubed minus 2x squared plus y minus 4y squared minus 3y plus x. What do you notice? Hopefully you notice that this time we have two variables going on here. We have x's and we have y's. So the way to tackle this is to think the alphabet. What comes before what? So x comes before y. So we want to deal with all the x's, then we want to deal with all the y's, and then at the end you'll have your constants or just the numbers. So for the x's, what is my highest degree? So hopefully you said that cube is the highest degree for my x's. So I have 5x cubed. Are there any other x cubes up here? No. So now let's get our squares. Switch colors. So I have a minus 2x squared. Any other x squares up here? No. So now let's take a look. Any x's? We do. We have a plus x. Hopefully you said, well, wait, Miss Connor, how is that a plus x? Guess what we forgot to do? I'm like, what? We forgot to do keep, change. So let's back up. Yes, I didn't forget, really. So since we have a minus sign, we should automatically change it to a plus sign. And when we change it to a plus sign, that means this is a negative 4y, this is a plus 3y, and then this is back to being a negative x. So in this case, when it comes to all the x's, didn't really bother us yet with the y's, but it would have. But this, in this case, is a minus x, not a plus x. So now we took care of our x's. Now let's take care of our y's. What is the highest degree? So the highest degree for my y's is the square. So I should have a minus 4y squared. Okay. Now I got to get the rest of my y's. Do I have regular y's? Yes, I do. I have a plus y and I have a plus 3y. So we got rid of the y, got rid of the 3y. I like to check them off as I rewrite them because it helps me keep in line. Once you see example 4 and 5, you'll know exactly why. So now, do I have any like terms to combine? Hopefully you say yes for right here. So this y plus 3y, that's going to give me a total of 4y. And it looks like everything else is just coming on down. So my 5x to the third is coming down. my negative 2x squared is coming down, and my minus x, and lastly, my minus 4y squared. So in fact, this is my solution. Okay? So I know your eyes are going to say, well, this y squared and this xy squared and this x squared should be able to match up. But remember, yes, they do have the same degree, but do they have the same variable? No, they don't. One's an x and one's a y. So you cannot combine those, okay? The only time you can combine them is the same variables and the same degree, okay? So now let's try number 4. Oh, yes, we are trying number 4. I know you're going to be like, no, but yes, you're trying number 4. Okay, so we have 3x squared minus 7x plus 2 minus 4x squared plus 6x minus 1 plus negative x squared plus 4x plus 5. So when you see this problem, don't try to take it all in at the same time. Work it step by step. First things first, we're dealing with subtraction here. So anytime I see subtraction, I should be thinking keep. And I'll put it in a different color, make it slightly bigger. Maybe a little bit more bigger than that. So I'm going to keep it. Here, you're going to change. Okay, and you're also going to change. Oops, let me clone this. You're going to change that minus sign to a plus sign. Okay, so you're going to keep that first parenthesis. You're going to change that minus sign to a plus sign. Then you're going to change this second parenthesis right there. But am I changing this last one? I'm not. The reason why, I'm doing addition right here. So in fact, so now instead of a minus sign, this is a plus sign. Instead of a positive 4x, it's a minus 4x. This is a minus 6x, and this is a plus 1. Over here, it's going to stay exactly the same. But now, we're doing addition all the way through. So we're going to do what we've been doing. We're going to gather all our like terms, starting with my highest degree. So let's take a look all the way through. What's my highest degree? And it looks like the highest degree is raised to the second power. So now, let's write them all down. We got 3x raised to the second power. So that's taken care of. You see why I have us cross things out? Negative 4x squared, cross that out, and a minus x squared. Okay, so now the next degree down will be our x's and our x's alone. So now I have a minus 7x. Then we have a minus 6x and plus 4x. And that's supposed to be an x. Okay, you see why I have us cross them out. Now what do you notice? We just basically have our variables left over, or our constant left over. So we have a plus 2, that's taken care of, plus 1, that's taken care of, and plus 5, that's taken care of. Okay? So now we got all our like terms together. So now, this is when it comes down to knowing our integers. So 3 minus 4, that will give me a negative 1. Negative 1 minus, remember there's a 1 there, minus 1 will give me a negative 2x squared. Next, negative 7 minus 6, that will give me a negative 13. Negative 13 plus 4 will give me a negative 9x. And then lastly, 2 plus 1 is 3, plus 5 is 8. As you can see, I don't have any other like terms, so there's my solution. So negative 2x squared minus 9x plus 8. Okay? So it may seem huge in the beginning, but if you remember the steps and walk yourselves through it step by step, you'll be fine. Okay? If you want, give number 5 a try. If you want to pause this, you can. Try to work it out yourself, and then we'll keep going. All right. So for those that already paused, and I know some of you probably didn't, but that's okay. First things first, I need to figure out when I'm keeping and when I'm changing. So from here, the first part, I'm actually going to keep this. And the reason why I'm keeping it is because it's dealing with the multiplication. I mean, not multiplication, it's dealing with the addition. So I'm going to keep that section, and I'm going to keep this section because we're dealing with addition. The only time that you're doing keep, change, change is when you're dealing with subtraction. So in this case, I'm actually going to make a change. Okay, so I'm going to change my minus to a plus, and I'm also going to change that last parenthesis, change them all from being positive to being negative. So now, where's my like terms? My highest degree is x to the fourth. We got all x's up here. So I have a negative x to the fourth. That's my leading coefficients, negative 1. Highest degree is 4. So now I need to go to the next one, which is my cube. So I have a plus, oops, got a little crazy with that 3. 3x cubed, okay, plus x cubed, okay. Do you see the importance of crossing things out? So I won't get too confused. Next one will be negative 4x squared plus 3x squared. Any other x squareds up here? Okay. How about any x's? Oh, I do see an x. Minus x. And it looks like what's left over are all my numbers. So not too many colors, but plus 3, minus 4, minus 9. So we got rid of the plus 3, got rid of the minus 4, and got rid of the minus 9. So now, let's get our like terms together. So we have negative x to the fourth. Then I got my like terms with the x cubed, so it was a positive 4x cubed. Because remember, there's a 1 that's there, and it's 3 plus 1. That's where the 4 came from. Then we have a negative 1x squared, or you can just say negative x squared. Oops. Minus x. That's the only x that we have up there. And then 3 minus 4 will give me a negative 1. Negative 1 minus 9 will give me a negative 10. So my solution is a negative x to the fourth plus 4x cubed minus x squared minus x minus 10. I know it seems like a lot, but remember, go through it step by step and you'll be just fine. So what I have the students do was going back to their pink paper or that homework assignment and have them do problems 4 and 5. So if you want to refer back to that paper, you can. Again, you can stop this and try to do problems 4 and 5. If you're still not sure, you can stick along. So we have for number 4, 2x squared minus x plus 2 minus 3x squared plus x minus 1. So again, we're doing subtraction. So the thing you should be thinking of is keep, change, change. So for this first part, I'm going to keep that first set of parentheses. I'm going to change this minus to a plus, and then I'm going to change this positive 3x squared to a negative 3x squared. I'm going to change this positive x to a negative x, and I'm going to change this minus 1 to a plus 1. So now I need my like terms, starting with my highest degree. And it looks like my highest degree is a square. So we have 2x squared minus 3x squared. Okay. Any other x squares? No. So the next degree should be my x's, which I have a minus x. And I also have a minus x. Okay. So that we took care of, that we took care of. The x's we also took care of. So now what's left over? This plus 2 and this plus 1. So 2x squared minus 3x squared gives me a negative x squared. But let me put it in its proper color. So a negative x squared. Then a minus x and a minus x, which gives me a negative 2x. And then 2 plus 1 will be plus 3. Okay? And then right here is our solution. And I know you're probably thinking, well, what else are we going to do with this? This is going to be the stepping stone once we start getting into factoring. And once you understand the adding and subtracting, the next stop is multiplying. And trust me, you're going to need to be able to identify like terms, and you're going to need to figure out the integers that are associated with them. So after number 4, move to number 5. Do the same thing. We are subtracting, so we need to keep this first parenthesis. We need to change this minus sign to a plus, and we need to change everything in that second equation. My highest degree is the cube, so we have 4z to the third power plus z to the third power. Any squares? Nope, don't have any squares. But we do have a minus z. Okay. Any other z's up here? No, because we took care of that, took care of that, took care of that. So now what's left over is this minus 6 plus 2. And now let's get our like terms together. So here you have 5z. Ooh, that's an ugly z, but you know what I'm saying. 5z cubed, because 4 plus, there's a 1 understood to be there. Then we only have our one lonely little z there. Then we have negative 6 plus 2, which gives me a negative 4. So my solution to this is 5z to the third power minus z minus 4. And that's my solution. Okay? So after we did some practicing, all right, had them complete the classwork, which is also on the website under the classwork section. I think it's for March 18th or 17th and 18th, but I actually have them work on it today since I kind of boost everything up a day because of the assessment. And the last part was their homework assignment. So here was four problems they had to complete for homework. So if they did not complete the classwork, they had to finish that up for homework. So depending on how focused they were in class, you probably didn't have that much homework. And also, if they didn't finish that, they had the homework here. If they didn't do the homework, everything is going to be due the following class, which for March 21st class, which was an A day, will be due on the 23rd, which is on Wednesday. And for the 22nd classes, which are B days, they're also going to be, theirs is going to be due on the 24th, which is the coming up Thursday. All right. So we have the classwork, which was two-sided, a total of 10 problems. The first side of the paper dealt with the addition, so there shouldn't be any keep, change for problems 1 through 5. They're all addition. On the back, problems 6 through 10 dealt with nothing but subtraction. So I didn't try to mix it up. Didn't try to like, oh, you're trying to trick me. So it's all addition on the front and it's all subtraction on the back. Okay, again, if there's any questions or concerns, just come see me during Wildcat Hour, first lunch, Tuesday, Tuesday and Wednesday preferably, so we can get all this stuff done. And if you need to come during CATS, you just need to tell me a little bit ahead of time. All right?